Good day and a warm welcome to the Swedish Maritime Administration here in Stockholm and Rosenvik. My name is Fredrik Backman and I am the head of ship management at the Swedish Maritime Administration. This is going to be a great day and we're going to present a project that is very close to my heart. The methanol conversion of one of our pilot boats, and this is one piece of the puzzle towards a fossil-free fleet within the Swedish Maritime Administration. I would like to start to welcome one of the keynote speakers, Johan Busser. Welcome.
Thank you. Thank you so much and good morning everyone. My name is Johan Busser and I'm a member of Parliament for the Social Democratic Party. I'm also in the Committee of Transport and Communication. I'm also from the city of Gothenburg, a city where we have the biggest port in Scandinavia, a city that has been dependent on shipping since it was founded. And we have a long tradition of cooperation between politics, between shipping industry, and also between universities. And that's a key factor to success. I would like to thank you for the opportunity to attend this event where the first methanol-driven pilot boat in the world is being launched today. I'm looking forward to listen to today's speakers and further discuss alternative fuels in shipping, as well as get inspired by all of you who are here. This launch of today shows that Sweden and the Swedish maritime sector is innovative regarding science and innovation. This is also an area where business, universities, and politics and policies need to join forces and work together. I would like also to say something about our Swedish national ambitions. Sweden is at the moment aiming to be one of the world's first fossil-free welfare nations. To achieve this, all actors in society must work actively together to reduce emissions. And this includes the government, companies, and different sectors, as well as the Swedish Maritime Administration. That is because the Swedish climate goals are ambitious. The Swedish Parliament decided by a large political majority to introduce a climate policy framework in the year of 2017. This framework consists of a Climate Act, a Climate Policy Council, and new climate targets, including to reach net zero emissions by the year of 2045 at latest, and thereafter negative emissions. This framework is the most important climate reform in Sweden's history and sets out Sweden's implementation of the Paris Agreement while providing long-term conditions for business and society in the transition. Sweden encourages all countries to adopt similar institutional arrangements in their own national settings. Sweden's experience shows that climate efforts offer many advantages. The country has worked long and actively to reduce emissions, primarily through various types of economic policy instruments such as a carbon dioxide tax and emissions trading. Since the year of 1991, when the carbon dioxide tax was introduced, the level of taxation has continuously been raised to respect the polluter pays principle. Sweden's carbon taxation levels for fossil fuels are today the highest in the world for households and services. At the same time, Sweden has enjoyed positive and clear economic growth. It is time to take the next step. The government is now investing in the transition of the transport sector, more renewable energy and sustainable consumption that also reduces impact in other countries. The government also wants to increase the impact of environmental taxes as a steering mechanism and apply the polluter pays principle. When the whole of the world must make a transition to live up to the Paris Agreement, this opens up enormous business opportunities. Swedish industry has the possibility to enhance its competitiveness by leading this transition, by exporting products that can help other countries reaching their goals. Jobs will be created in Sweden. This, in turn, will enhance people's quality of life and well-being. The pace of climate efforts needs to speed up if Sweden is to meet its climate objectives. The government has increased investments for the climate transition of the industrial and transport sectors. We have now doubled our support for the Industry Leap initiative, which, for example, helped fund the hybrid project of creating fossil-free steel. We have also added valuable assets to the Climate Leap, funding regional and local initiatives to reduce greenhouse gas emissions, making the transition possible across the country. I'm also pleased that in the budget bill for 2021, the government has allocated investment to the Swedish Maritime Administration, and especially for transition to a fossil-free fleet. We have also extended our support for the eco-bonus scheme, which aims to hasten the shift of goods transports from roads to shipping. In order to further reduce emission and reach our goals in reducing emissions from the transport sector with 70% until 2030 compared to the year of 2010, this launch of FASTWATER today, which is a project that is being funded by the European Union and also by the Swedish Maritime Administration, and they are cooperating together, and that is I'm very impressed about this launch of the first fossil-free pilot boat in the world. So once again, I would like to thank you all of inviting me, and I'm looking forward to get inspired by all of you who are here. And once again, thanks a lot for listening. Thank you. Okay. And now I have a colleague here as well, who is also a member of parliament, and it's Anders Hansson, who is a member of parliament in the Transport and Communication Committee from the Moderate Party. So please welcome Anders.
Thank you, Johan. And ladies and gentlemen, thank you, Director General Katarina Norén from the Swedish Maritime Administration for giving me the opportunity to participate in this historic day when we launched the first pilot boat that runs on green methanol. It's indeed an interesting project performed together with, for example, the SSP and the Methanol Institute, and of course the Swedish Industry and Commerce. Sweden depends heavy on our shipping or maritime trade for our export and import. More than 90% of Swedish trade goes by sea, and the shipping business employs over 100,000 persons or employees. Without the top-class shipping that Sweden has today, our trade and prosperity will be considerably less. I'm glad to see that more and more of my fellow parliamentarians recognizes this fact. Previously speaker Johan Büser told us about politics and about the importance of changing from fossil fuels to non-fossil fuels. And this project is one step towards more environmental friendly shipping. Although my colleague Johan Büser and I often disagree on political matters, I can assure you that concerning the need for shipping to do its part in changing to more environmental friendly fuels and work for greener shipping, we are totally in agreement. It is both interesting and gratifying to see the shipping industry, and especially the Swedish shipping industry, make great efforts to reduce their environmental impact. I say well done and keep up with the good work. We must all do what we can towards a more sustainable future. Sweden has a very long coastline with over 2,400 kilometers from Haparanda in the north to Smygehuk in the south and up to Strömstad in the west. Over 100 days a year, we need icebreaker ships to clear paths to the ice to other northern ports. We also have a great possibility to start with inland navigation through our Great Lakes and our rivers and channels. In every aspect of this, shipping and trade, we mustn't let go of our control and security on the seaways. Piloting and pilot boats are necessary to make sure that sea travel is safe. Although we of course also look with great interest on new techniques for safe piloting and safe traveling. The Swedish Maritime Administration owns and commands a fleet of over 100 different ships. Of that number of ships, 70 are pilot boats, on which approximately over 200 pilots work. Today, one of these pilot boats is being remade to be driven by green methanol instead of fossil fuel. A small, but certainly very important step towards a brighter and greener future. If it's easy to convert existing engines to green methanol, and it could be done at relative low cost, we are on the right path. I much appreciate the work that the Swedish Maritime Administration, as a member of this project, the FASTWATER project, has started in trying to make their ships and boats more environmental friendly. As I said earlier, when I gave credit to the shipping industry for its work, I also want to give the same credit to the Maritime Administration for its work with the launching of the pilot boat we see here today. Well done, and keep up the good work. The future of shipping is bright. Demands from consumers or customers on more greener transport ways will increase. Government agencies and administrations must do their part in show that a conversion is possible and also necessary. If we can do this together, we will certainly be on the road to success. I wish all parties involved in this project all the best, and I look forward to hearing more about this project and your success in the future. Thank you very much. And now I will present the next speaker, and it is a project manager for the FASTWATER project, Sebastian Verhelst. I got the name right, I hope.
Yes, you did. Thank you very much. All right. Also from my side, a very warm welcome to everyone in the room, to you following online or rewatching this. So my name is Sebastian Verhelst. I'm the project coordinator of FASTWATER. I work at both Ghent University in Belgium and Lund University in Sweden. And in both places, actually over 10 years ago, we started looking into this simple molecule called methanol. And to explain why we really started investing research into this, research that has borne fruit as we can happily celebrate today, let me go through a couple of things that we worked out many years ago. So at that time, we were looking for potential energy carriers and powertrains for transport in general, but then maritime transport in particular, and really thinking long term. So if we think decades from now, what could energy carriers look like? What types of fuels or other energy carriers would we be able to use in which type of powertrains? And to start that exercise, we needed a number of criteria, of course, to guide us along. The first one is pretty obvious, of course. This needs to be a sustainable thing. And with that, if you come to think of what that really means, it means that all of the materials that go into either making your energy carrier or your powertrain, that you must be able to do that in a closed cycle. So think circular economy. That's a first given, sustainability. If you think about transport and the huge challenge we're facing with phasing out fossil fuel, clearly any alternative that we come up with must be scalable. That means, again, these materials that we're going to use to build energy carriers, to build powertrains, that means they must be abundantly available. If we do it like that, we also simultaneously ensure that those become affordable, that we can really scale it up, not just because of the fact that we have enough resources, but also that we can afford them. And then, of course, anything to do with transport, and then in particular heavy transport, such as maritime, we also need things that are storable. We need things that are sufficiently compact, because we need to ensure range and payload. If you combine these three criteria, sustainability, scalability, storability, I think it's quite easy to see that it starts lining up to, first of all, there always being a need for fuels. There's many things we can and should do electrically, but there's also limitations to that technology. For quite a number of applications, we need the energy density of a fuel. But obviously, those fuels need to become renewable. We need to move away from fossil fuels. And then for those applications where you really need the storage density, there will always be a need for liquid fuels. So liquid e-fuels are definitely going to be needed for a number of applications. So if you combine these things and then look at what we set out to do within the FASTWATER project, basically we see we have to go for renewable energy in the long run. So green electricity is what we will power a lot of things with. This is sustainable, this is scalable. It's a huge challenge to scale up renewable energy, but we know we have enough of it, so that's a comfort. And then look how we can actually make that manageable, that green electricity. How can we power heavy transportation with this? So then we need to look for things with which we can store that power. So we're looking at producing green hydrogen. We're looking at capturing CO2, carbon dioxide. These are things that are abundantly available, so that answers the scalability issue. So once we start building things from these scalable resources, we need to build smart things, and we think that methanol is a very smart choice. It's the simplest hydrogen carrier that is liquid at atmospheric conditions. So that makes it storable. Having a liquid means that the number of applications you can tackle with this is much wider. On the use of methanol, obviously CO2 will be liberated again, but if you start from captured CO2, you set this up in a closed cycle, so you don't emit any net CO2. You don't contribute to any CO2 rise in the atmosphere. So over 3 years ago, we started thinking, okay, there's a clear need for an alternative in maritime. We think this is a really strong candidate. We weren't the only ones thinking that. We saw a lot of interest growing around us. But we also saw that there were a number of challenges that still needed to be tackled. So what we identified 3 years ago is that, first of all, a number of people really wanted to start moving into this, but were hindered by the fact that there were no methanol engines commercially available in the power range, let's say 100 kilowatt to about 10 megawatt. I'm happy to say that the first engine has now been launched commercially within our project. More of that you will hear a bit later this morning. A second big challenge was, okay, we need to move away from fossil fuels. Once you start looking into different fuels, it's a whole value chain that you have to start changing. So that this whole chain from producing renewable fuel up to actually sailing on this renewable fuel, that's a daunting prospect. We needed to have demonstrators out there. We have managed to do that, and stay tuned for the following talks going into each of the parts of this value chain. Then also important, of course, also very frequently a hindrance to introducing new things is rules and regulations. There were embryonic rules and regulations a couple of years ago. It was possible to do this, but again, we lacked experience with them. We lacked demonstration on different vessel types to really get this into our fingers. What works, what doesn't work, how should we tackle this? So recognizing these challenges led us to submitting this project proposal to the European Commission and then getting it funded. So we started about 18 months ago, June 1st, 2020, with a 4-year project with 14 partners that I'll show in a minute. And so what we are doing on a daily basis now is working on engines, working on different methanol engine technologies, working on different power ranges to really make these commercially available. So we have the first product out there already and more coming soon. But ultimately, these engines, of course, they need to end up in vessels. So within this project, the one you are going to hear about today is the launch of the pilot boat. You're going to look under the hood in a couple of minutes. So that's our first demonstrator ahead of schedule. I'm very happy to report. Besides that, you also see on the top left a tugboat that's going to be operated in the port of Antwerp in Belgium. So less than a year from now, we will hopefully have a similar launch event to also launch the first methanol-powered tugboat worldwide. And then on the bottom right, you see a Coast Guard vessel. That's 2023 we're looking at. We're going to demonstrate that in the coastal waters of Greece. And then simultaneously, we're also working out the design of a river cruise vessel, what it would mean to convert such a river cruise vessel that you see on the bottom left to the use of methanol. So that's a number of partners, of course. I've already mentioned that. Quite a number of pieces of the puzzle have to start lining up to make this happen. So we're spanning quite a number of different partners, from fuel suppliers, ultimately, of course, to vessel owners, such as the Swedish Maritime Administration. Even that is not enough, so we're very happy to have these partners on board, but we're equally happy to also have quite a number of partners on board in our advisory boards that helps us with advice on how to really make this a reality, how to exploit this, where to identify early movers, to help us out with these guidelines, to tweak them so that this all becomes feasible. So with that, thank you very much for your attention, and I'll happily pass it over to Mr. Eelco Dekker from the Methanol Institute.
Thank you very much, Sebastian. Good morning, all. First of all, a great thanks to the Swedish Maritime Administration, first of all, for hosting today's launch event and for giving us the opportunity to present briefly to you. On the off chance that you may not have heard of the Methanol Institute is a global industry association. We represent the world's largest methanol producers, methanol distributors, technology providers, and increasingly also methanol consumers, especially also on the shipping side. Companies like MSC, Oldendorff and Maersk are all members that have joined the Methanol Institute over the last year. Speaking of use of methanol as a shipping fuel, you only have to open up a shipping magazine or read a maritime website and you see all sorts of articles and headlines about promises of climate neutral, sustainable alternative fuels. What sets apart the different headlines, whether it's the announcement from Maersk of the 8 container vessels or Express with their 16 feeders, the 24 million euro subsidy that the Dutch government has provided for a methanol project with companies like Fugro, Van Oort, Boskalis and many others, is that methanol is not 5 years out. Methanol is happening today. We have approximately 55 methanol-powered vessels on the water today or on order. There are more vessels on order as we speak, and it's only a limited amount of time before we will see the first 4-stroke engine, and really almost all major engine manufacturers are working on their methanol solutions. But the question is why? Why are people looking at methanol as an alternative fuels? And we had 2 speakers from the Swedish Parliament here today. Policy is an important driver behind what's happening in the shipping industry. And we tend to forget that actually the first driver for the shift to methanol as an alternative fuel was not CO2. It was the introduction of the sulfur emission control areas by IMO. So in 2015, Stena Lines introduced the Stena Germanica that operates on methanol in the form of a retrofit. Since then, CO2 has become much more of a topic in shipping. On the international stage, we have the IMO that is trying to drive the international shipping industry to lower carbon emissions, starting with 40% by 2030 to 50% reduction by 2050. But you can imagine that if you try and do this on the global stage, it's quite challenging, because where Western member states, Western countries and Western stakeholders feel that IMO is not moving fast enough, we have other parts of the world that are saying, well, hang on, we're going too fast. They can't even agree on the definition of what does it mean to reduce carbon. Are we talking about tank to wake, or are we talking well to wake? So it's still a very complicated discussion. And so despite all the optimism at COP26, I'm afraid that it will still take IMO quite a long time to come to an agreement. And then on the other side, we have the European Union. The European Union introduced the Fit for 55 package in June this year, which has implications for a lot of different industry, for a lot of different energy carriers. And in that package, there are two specific pieces of legislation that have a very big impact on the shipping industry. On the one hand, Europe aims to introduce the emission trading scheme for shipping as well, meaning that gradually, as a shipping company, you have to start paying when you're emitting carbon. And at the same time, Europe also has introduced the EU fuel maritime regulation, which is looking at the fuel standard. And similar to what the Fuel Quality Directive did for road fuels, the EU fuel maritime regulation is looking to reduce the actual carbon footprint of marine fuels. So where does methanol come into that picture? Now, as I briefly touched upon, methanol, whether it's fossil methanol or renewable methanol, has an immediate benefit when it comes to reducing local air emissions. It can also drive CO2 emissions down, especially when you start producing renewable methanol. And the question we get asked often is, how much renewable methanol is available? When will it be available? And in order to be able to answer that question, we first need to look at, okay, but how do we actually produce renewable methanol? And I'm not an engineer, I'm not a chemist, so I've definitely oversimplified things here. But really you can bracket or put the production of renewable methanol in 4 different buckets. Today, most of the methanol produced worldwide is made from natural gas. If I switch over from natural gas to biogas, I don't actually have to change anything to my methanol production process, but I can start producing biomethanol. Another way of producing biomethanol is by gasification of either biomass or municipal solid waste, which gives you a syngas, which is then easily reacted into methanol. Now, the next speaker after me is from Södra, and he will talk in much more detail about the specific process, which I have simplified by calling it distillation. I know that's not completely doing it justice, but we'll hear more about that. And then the last pathway that was also briefly touched upon by Sebastian Verhelst is the production of so-called e-methanol, or in legislative terms it's called renewable fuels of non-biological origin, which means as much that we take renewable electricity, convert the electricity into hydrogen, and then react the hydrogen with carbon dioxide to produce a methanol. And in the chart that I'm showing on the slides here, I have tried to summarize what we have seen in terms of various announcements of different projects. And roughly we see projects equating to order of magnitude about 2 million metric tons of renewable methanol in the next 10 years or so. Probably some of those projects will not come to fruition, but then again, every other week there's an announcement about a new project. So we're quite optimistic about where this will be headed. But future will only tell, and it's really a question between supply and demand. It's chicken and the egg discussion as usual. So to summarize, why methanol? Methanol is liquid. And normally we would talk about all these different bullets in individual slides, but we don't have the time for that. So methanol is liquid at atmospheric pressure. It's available in all major ports around the world. It results in immediate lower emissions, so better local air quality, but it has the potential to reduce carbon dioxide as well. And something that is often neglected in these discussions, but methanol is biodegradable. So you shouldn't have a spill, but when you do have a spill, methanol actually causes very few problems. Methanol is also something that can be made, as explained briefly, from a wide range of renewable feedstocks. It can be cost effective, and when you look at the various studies, the transition to alternative fuels, methanol is one of the lowest cost solutions when it comes to total cost of ownership. So really, methanol is a future-proof fuel, but it's a future-proof fuel which is available already today, and it's here to stay. And with that, I'd like to thank you for your attention, and I'd like to hand over to Johannes Bogren. I hope I pronounce your last name correctly.
Good enough.
Good enough. Thank you very much.
Thank you so much. Thank you, Elko, for the introduction. Great to be here and talk to you about our product that we call liquid forest biomethanol. And we call it liquid forest because it's simply the Swedish forest in liquefied form. First, a few words about Södra, the company that I represent. We are a Swedish forest industry group. We are owned by 52,000 forest owners in the southern part of Sweden. And our task as a company is really to create a value out of this versatile raw material. And we do this by creating different kind of forest-based products. We operate sawmills that produce products that are used for construction and for building houses. We operate pulp mills that are used to make paper pulp, used in different paper products like tissue, office paper, packaging, all kinds of products. And then at one mill, we produce something called textile pulp that is used to make textiles. And the past decade, we worked a lot on our operations to be really resource efficient and being energy efficient. And this has allowed us to start selling green electricity out on the grid. And we also then supply different kind of co-products out of from the mills. And we talk more about one of those today, our biomethanol one. But let's go out to the forest and where it all starts, because this is actually origin of our biomethanol. Our forest is owned by our owners. They operate them themselves. They take all the decisions. We kind of say that they are the CEO of their own forest. And this is a great way to get a biodiversity because everyone has their own values and take their own decisions. This raw material is then harvested and we use it at our mill. And the species that we use when we make our biomethanol is spruce and it's pine and it's birch and it's aspen. We also actually had an inauguration about a year ago of this plant because this is our biomethanol plant. And it's the world's first of its kind. It's based on in-house technology from Södra, and we use a stream from the nearby pulp mill that is just behind the steam there. The capacity of this site is 6.5 million liters of biomethanol as the design capacity. And since we use wood as the input material at the site, all the energy that we use is renewable. I would say that this plant is really a good example of what you can achieve when you are resource efficient, because we don't do anything new. We just take out another stream that we today don't need to use anymore. Just try to go a little bit into detail of what we are doing here, because like I said, we are producing pulp. This is a paper pulp mill. And what we do at this pulp mill is that we take wood chips, we digest it together with chemicals in order to liberate the fibers so that you can make different kind of paper products. This pulp is washed and it's bleached and it's dried. And that's kind of the normal head component that we produce up there. And during this operation, biomethanol is also formed together with all other kinds of different volatile compounds. And this mixture we call raw methanol because it's composed of different things and it's really stinky. It's really stinky. And what we need to do is to purify this stream. We remove all the components and left we are with our methanol that we then can sell out into the market. So that's a simple explanation of how this works. Sounds easy, but it's not. It has taken us many, many years to develop this. Just to give you an idea about the journey that we have been on, we actually started this project roughly 10 years ago with the first idea of how we could start supplying the next generation of biofuels. A year later, we had to construct a special lab just because the product is so stinky. And we did it in one of our mills in Mörrum with promising results. So 2 years later, we moved on with a pilot plant. And a couple of years later on, we saw that, yeah, this is commercially viable. Let's move ahead with a pre-project and see how we could actually construct this. And 2017, our board took a decision to move on with the commercial plant. And just the day after, the procurement phase and construction phase started. And during fall 2019, we fired up the plant. And it was really a bumpy start, I must say that. Sometimes you had 2 steps ahead, 1 back, sometimes 3 back. You know how it is. This is really tricky. But roughly a year ago, during the autumn 2020, we had an inauguration with the Minister of Enterprise, Ibrahim Baylam, who pushed the button. And since then, the mill has been working really, really good. We are now up at the design capacity, and we are selling this product out regularly out in the market. I was really pleased now also with the pilot boat here being bunkered with our methanol. The application, let me put it like this. The methanol market is huge, 100 million tons plus. The biomethanol market is really a niche market. We try to find those that value a product that is based on the forest. And today we sell it into applications like in pharma, we sell it into the flavor and fragrance industry, and of course to the biofuel market, which is the big one. There's a huge difference, of course, compared to our volume and the total market volume for methanol. But this kind of technology is possible for all kinds of pulp mills all over the world. And if we look at that potential, then we're talking about 2 to 3 million tons of biomethanol that might be produced from these pulp mills. A really resource efficient way. Talking about biomethanol as a fuel for the future, well, there are different ways of using biomethanol. Our biggest customer today, they produce biodiesel according to the FAME process. That's one way of using methanol. Another way is to use it as a low mixture into gasoline pool. Or, as we're learning today, use it as a fuel directly. And if you use it as a fuel directly, you have a huge, you save a lot of greenhouse gas emissions. We are talking about, with our numbers, 94.4% that you save. And if you compare it to other kind of fuels that also emits carbon dioxide, also those renewable alternatives, you see that HVO or FAME or ethanol, they emit 5 to 6 times more carbon dioxide than biomethanol. And biomethanol is really a very good example showing how you could work resource efficiently. So I'm really happy to be here today with this kind of new chapter also for biomethanol being used as a fuel directly. And I'd like to congratulate everyone involved with this pilot boat conversion. I think this is a great way to show how we all can cooperate together and save the greenhouse gas emissions. And by that, I would like to end and just remind everyone that the future is made of trees. And now I hand over to Magnus Persson, who will talk from Multi-Fuel and Wash.
Thank you. Thank you, everybody, to be here. I will say a special thank you for the Member of Parliament here and also General Director for the Sjöfartsverket, the Swedish Maritime Office, project delegates, and ladies and gentlemen. Today it's an honor for us because this project here, but we have been chosen to be supplier of handling the fuel. It's 100 years ago since we did the first fuel distribution installation south of Halmstad. And this is great to see that new fuels is coming to the market instead of what we have had before. As you everybody know that we as a politician said here, we need to have some transition over a period. And we have been trying for many years now to be Scandinavia's most innovative company for finding the distribution solutions. And today we're talking about the challenges to handle new type of fuels, as a methanol is one, but we also will see a lot of new versions of that. A little bit of our company, but we are specialized of a distribution system for liquefied fuel. with pressure less than 10 bar. We have been in this type of project with dimethyl ether longer, but the tax authorities killed that, unfortunately. We also work with wash for vehicle, car, truck, buses. Of course, we need chemicals there also. But the one other area is that we are supporting transport sector. We have close work with some of our biggest truck car manufacturers to look for the pollution and environmental issues around new type of fuels. So the industry is a very, very important issue to give them a solution to handle all this new type of fuels. Challenges with such a distribution system is methanol. What is methanol? Our experience now, we would like to see, we will see different versions of methanol, but in general terms, they're talking about methanol. But because of which application we shall have it. Here we have a small pilot boat, but we have even smaller engines, but they're also talking about super big engines. So it's keep up to understand what is the purpose of the fuel. We can see here pure or blend, but the M-pure will have for the coming fuel cells, methanol fuel cells. In this project, the MD97 methanol, also talking about methanol, but it's an ignition improver, different engine techniques. We have super specialists here for this type of engines. Then we have the M100, which is with lubricants, which is coming with ignition engines. Coming here from China, but also a lot of other manufacturers who are really interested to tell that they have solutions. This is a fantastic presentation that a new real life working for this to reach goals for the environmental. Then we will see also the other mixture here with a new type of flex fuels. Then of course everybody's talking about toxic. What is toxic for what? That is it toxic for human being, living animal, nature, water? If it's toxic for one situation, it's not in general. So it's also important to understand what is the need and how is the danger. If petrol had come today as a fuel, it has been sold by recipe in the pharmacy. So it's a way to understand, and the society need to be educated and trained for it. Other thing I will address, especially to the politics here, is that we have a mission here with regulation, and especially in some of the European countries, the fire class 1 product integration in the industry, which is normally worked with diesel or marine gas oil. That's the mission, to understand the safety aspect and to take care of it, handled. So it's have a new fuel in combination with that. It's when we have 170 boats or something like that. Some will have a new fuel that really needs to have a training session, understanding with all staff handling it. And of course, it's very dry with the methanol, so it's need to have lubricants also. To work with a distribution system for this type of a product, MD97, then we need to take in consideration different type of density of all components. But we also have new corrosion questions with absorbing water. Of course, flow speed, that depends on which type of application. And of course, the safety handling, both from trucks, depots, and on-site boats. people shall not be afraid, but increase of understanding is super important. So please address to the Swedish Maritime, education and training is really important to increase the understandings. We can see also that to handling lubricants, additive and tank trucks is a process, and we will be more aware of it and find a very good solution. Here we can see what we have delivered to Oxelösund. It's a complete movable solution, 10,000 liter storage capacity with 7.5 cubic methanol and 2.5 cubic ignition improver. But we shall also have lubricants, and it's blending inline during the process, filling the boat. We shall have approval for all fire rules and safety rules in Sweden, but we have here done a construction which is fulfilling the ATEX rules for Europe. But the secondary containment, leak detection, blending, special requests from the owner of how the process shall be handling to the boat, safety distance to the sea, grip-free connections. And then, of course, we can see, I take the opportunity to have some company identity and profile on it so we can see who is the owner. It's always difficult to sell a fuel which is flammable, no packaging, hazardous, safety aspect. Therefore, the corporate identity is important to show what we really would like to have. I would like also thank you that it has been a fantastic opportunity to us to increase our knowledge to handle new type of fuels for Sjöfartsverket and this MD97. But I must take the opportunity to give you some brief information what we are doing more in the methanol area. Because Denmark, our neighbor country, they have decided to go for 90% exchange of petrol to methanol until 2034. Very soon. And they are producing 3 types of this unit for blending M100 to petrol, but also M100 for lubricants for spark ignition engines. So different application need different type of engines, and then also different type of mixture of products. So we can see here very soon that MD97, M100 with lubricants, M-Pure and M85 will be the new fuels on the market for many years ahead. And in Denmark, we will see Power-to-X, as electrolyzed on water, merged with green carbon dioxide. That will be then more or less no limitation of availability. It will be a fantastic possibility. And I'm representing a very small company here, but when a company like Maersk, Ørsted, and Sjöfartsverket understand what is the future, this will really be a possibility. But Sweden can't do it by themselves. We have a fantastic pilot project here. We're going ahead, but to be a success story, it must be also introduced in other European countries, like Germany, Netherlands, Austria, and Poland. And we have one of the issues when we come to integrate the Fire Class 1 product above ground to be flexible. Where will the market be and how much shall we invest? That means in a lot of these countries, they are forbidden to have fire class 1 product above ground, like Germany, Netherlands, Switzerland, Austria, and Italy. Here in Scandinavia, are we very open and look more for a risk assessment, how to go. So the regulation in Sweden are in general in place. It's a matter of risk assessment, training, and evaluation, what is needed. So I think my time is over. I'm really glad to be invited here to speak for us, and thank you for the administration and the trust for our solutions. Now I introduce Alice from SSPA.
Hello, thank you very much for the opportunity to be here. My name is Joanne Ellis, and I am a senior researcher and project manager at SSPA, which is a maritime consulting, testing, and research company located in Gothenburg, Sweden. We are a partner in the FASTWATER project, and I said very grateful for the opportunity to be here and be involved in such an exciting project. Being able to supply methanol as a fuel on a vessel, procedures and processes for bringing the fuel on board is really important for the uptake of the new fuels, and is consistently identified by ship operators and owners as something that they consider when deciding upon new fuels. As well on the European level, the European Parliament recognizing the need for infrastructure for uptake of zero and low carbon fuels is developing regulations for deployment of alternative fuel infrastructure. And on the side of methanol, there have been developments going on regarding bunkering specification developments on a European level and technical references to be able to have processes in place to make the process of bunkering methanol become more routine and understood. And of course, methanol being a liquid fuel is very similar to other conventional marine fuels that are bunkered, and the same processes that have been used to bunker these to ships can also be applied to methanol. For example, with ship-to-ship bunkering, a way of bringing the fuel on in large quantities suitable to large vessels. There has been one demonstration so far in 2021 at the Port of Rotterdam. Here you can see a large chemical tanker being bunkered with an existing methanol barge, demonstrating the process can be carried out very efficiently and using a lot of the existing infrastructure that is in place, which is quite a benefit for an alternative fuel. Another method up to date to now, truck-to-ship bunkering has been used the most for methanol, which is the case for new fuels as they're coming in when there isn't a market yet to have bunker vessels delivering to large vessels. Some examples already in Stockholm, the Viking Miriala has bunkered methanol from the quayside from a truck for their onboard methanol fuel cell installation. And of course, in Gothenburg, we have the well-known example of the Stena Germanica that has been bunkering methanol by truck since 2015 and has had hundreds of safe transfers of methanol to the vessel. And in this case, they have built some specific infrastructure at the shore for facilitating faster transfer of the methanol by pumps and additional safety equipment. Third method of providing fuel to ships that also has been tested and applied to methanol is using a land-based storage or pipeline to transfer the methanol to the vessel. And this is being done now for the methanol tankers and chemical tankers owned by Waterfront Shipping, which bunker from a shoreline pipeline connection while loading methanol cargo. And now, today, we will see the first ever demonstration of bunkering of a small pilot vessel, which is using a purpose-built dispensing facility, which we heard about from Magnus. And it's very exciting to be able to be part of this project with this demonstration. I'm going to show a short film demonstrating how the methanol was supplied to the Oxelösund pilot boat station and how it's going to be brought on board the vessel. can see it being transported in a road tanker, methanol from Södra, the green plant-based methanol, renewable methanol, arriving at the Oxygen pilot boat station, and using procedures in place, of course, road transport of methanol and other flammable liquids regulated and a common procedure today. Connecting the pilot boat methanol station constructed by Malte to the truck to transfer the methanol, following the safety procedures required. You can see here, for example, grounding the truck to the bunker station to ensure there's no electrostatic charge buildup, which is important for the transfer as well. Another safety feature is the hose connection is a drip-free connection to ensure when there's disconnecting after bunkering that there will be no spill even of a small amount of methanol. Also important from a safety perspective and required is that the tank level is connected to the tank level gauge is connected to the truck, so when the maximum level is reached, there's an automatic shut-off, preventing any sort of overfill problems. And required safety equipment, of course, goggles and gloves, and required for the purpose for handling methanol and starting up the transfer procedure. The pump is part integral to the bunker station, so the pump is starting here and transferring the methanol into the station, the M97 methanol station, where before it's loaded to the pilot boat, the methanol will be blended with the additives. And here as well, the connection to the pilot boat is also of the drip-free type to ensure, again, no loss of methanol after disconnecting. You see the connection here to the pilot boat bunker pipe. And also there is a tank level gauge on the pilot boat that will be connected to the pumps to ensure that as soon as the maximum level is reached, there will be an automatic shut-off of the pump and no risk of overfilling. And as well, for starting and stopping the methanol transfer, there is a handheld device that it must be depressed, and as soon as that's released, the transfer will stop. Another safety feature. Ensuring that being able to stand in location and observe both the transfer of the methanol and the station. It's finished and off goes the pilot boat. And what we're going to hear next, two speakers talk about how the engine conversion the engine work has been developed for the pilot boat, and as well how the ship conversion has been done. So thank you very much, and I'm happy to have the opportunity to introduce Mr. Albert Byström of the Swedish Maritime Administration, who has worked so hard and been instrumental in this pilot boat project. Thank you.
Thank you very much. My name is Albert Byström, and I, from Swedish Maritime Administration, I will host this presentation along with Patrik Molander from Skandinaus. And we'll start off talking a bit about what a pilot boat is. The pilot boat, you could say, is the link between the shore and the ship that needs the pilot assist. We take the pilot from shore or from the ship to shore, vice versa, 365 days a year and throughout all weather conditions. Since the ship traffic is going on every day, all over the year, then that means we meet different types of weather, different types of conditions. And we need to have reliability on the systems on board. And by having said that, I think the operation that we do is quite good, and we have up to date, I think there is about 95% delivery rate on our operations. And then you can ask us as well why we choose methanol in this kind of installation and not other types of technologies. And we need reliability. We need a functional system that is robust due to the conditions the boats are put into. And in this case, we also looking into energy storage. And for this type of installation that we have in pilot boat 120, which we have outside, energy storage for methanol is at this stage the best option. And having said that, I will hand over the floor to Patrik Molander that will talk a bit more about the installation in the pilot boat itself.
Hello, my name is Patrik Molander. I work for the company Skandinaus, and we are responsible for the design work, naval architecture work on board the methanol converted pilot boat, and also the engine delivery. This boat, which you see on the screen behind me here, that is the pilot boat 120 SE. This is probably one of the cleanest ships on our waters worldwide. It operates on biomethanol, and later in my presentation I will tell you more about in detail what makes it so clean. I will start by introducing our company, who we are. Then I will introduce you to the methanol design on board the ship, and we will end by describing the engine and the engine functionality. So our company Skandinaus started in 2005. We have been into methanol design since 2009. We like to call ourselves as methanol pioneers. And there's some substance in that saying, because we have actually taken part in a lot of methanol conversions and methanol design projects over the year, the last 12 years now. All the way from large RoPax ships to pre-studies, smaller boats, and now also pilot boats. And we've been involved in many real projects, so real conversion designs. We started a sister company, Enmar Engine, that will only focus on methanol engine production. Within Skandinaus, we have developed methanol engines for 5 years now, and we have seen that there is a huge request on the market for this size of engines. So that is the background for that. This is the pilot boat 120 SE. It operates in Sweden by the Swedish Maritime Administration. It has a length of 14.4 meters and width of 4.6 meters. So it's a typical pilot boat. It has a single engine, a fixed propeller, and this is the boat converted to operate on methanol, which you see on the illustration here. The boat is, if we start from the front, we can see a forepeak. Then we can see the bulkhead below deck. We have the engine room. And then aft we can see the fuel storage room or the tank room, which is also the rudder room. I will tell you why very briefly about why we should use methanol as a fuel, why it's good for us, and then you have to allow me to become a bit more technical in my presentation. I hope you appreciate it. So why should we use methanol? Methanol is a clean burning alcohol. There's no sulfur in the fuel. And if you don't have sulfur in the fuel, you will not have sulfur oxides formed in the combustion. Sulfur oxide is in some cases recognized as SOx. So this boat will not, or using methanol, will not lead to any SOx emissions. Methanol is a simple alcohol, and when combusting methanol, no particles are formed. It's actually physically not possible for methanol to form particles or form soot, which soot and particles are in other words for long carbon chains. And this is not possible, so we will not have any particular matters formed from this type of engines. Methanol also reduces the emissions of NOx, nitrogen oxides. And nitrogen is not part of the fuel, but it's part of the air that goes into the engine. And in the combustion, in the chemical reaction, NOx is formed. And since we don't have, since methanol burns cool, it has a cold combustion, we will have reduced emissions of NOx. As my previous speakers told us, methanol has a very good potential from being produced from renewable feedstocks, both as biomethanol but also as e-methanol, which is produced from renewable electricity. Methanol is biodegradable, does not bioaccumulate in aquatic environment, so we shouldn't have a spill, but if we have, especially in a marine environment or marine sensitive environment, it's highly important that we do not cause any environmental problems. It's a liquid fuel that is easy to transport and distribute. And from a logistic and transport point of view, we can always discuss different technologies for how to transport it and challenges, and it is an important facts that being covered here. But liquid methanol is more like diesel to transport than transporting a gas, for instance, cryogenic gas or compressed gas. So it is, after all, a quite simple mixture or quite simple liquid to transport. And it's also through many projects shown to be a good engine fuel. I will show you some numbers here. This is just a bar graph showing that if we combust 1 kilowatt hour, one energy unit of diesel, we will emit a certain amount of CO2. So if we combust fossil diesel 1 kilowatt hour, we have the emission of 268 grams of carbon dioxide. And the potential is to get down to zero by using e-methanol. And we heard earlier a very good example of biomethanol, which also has very good carbon dioxide emission performance. The ship pilot boat 120 SC is a conversion of an existing vessel. There used to be an IMO Tier 2 engine installed on board, where the emission of NOx is 7.7 grams per kilowatt hour. Producing the same power, we reduced this to 2 grams for this engine that is installed now. And as I said, particulate matters are not formed in the combustion of methanol, so this is reduced to zero. And a typical example is the previous engine that was installed on board a pilot boat, where the emission is 0.4 grams per kilowatt hour. I will go through some design challenges of a methanol ship. Methanol has different properties of diesel. It's not in all cases a worse or a more difficult liquid to handle, but we have a standard level of how to handle and how to make a diesel installation, how to handle the diesel fuel on board. Methanol has different properties. And some of the challenges we need to cover here is that it's a low flash point fuel. Methanol is the flash point of a fuel is easiest described by having methanol or any fuel in a pool. So if we imagine that we have a spillage or a pool of methanol in front of us, and then we have a certain environmental or surrounding temperature, in this case 11 degrees for methanol, the vapor that is produced from this pool is enough to create a flammable atmosphere. And if we have an ignition, we could have a fire, or we will have a fire. The same goes for diesel, but here the temperature is 60 degrees. Gasoline requires a temperature of -40 and LNG -188. So since 11 degrees Celsius is a quite normal temperature on board a ship in our environment, we need to find a design how to handle this challenge. Methanol flame is almost invisible in daylight, so we need to find another way of detecting a methanol fire than the traditional way. The reason for methanol being more difficult to see in daylight, that is that it doesn't produce any soot. So the fire from a diesel fire or gasoline fire has this intense orange yellow color, while from a methanol it's more of a blue flame. On the other hand, it's we have some benefits of fire suppression. Methanol has less heat radiation than a corresponding diesel or gasoline fire. So if we have a fire, the heat radiated from the methanol fuel is lower. So you can stand very close to a methanol fire without getting without hurting yourself from burn heat injuries. And it's also possible to extinguish the fire with using water. We have some challenges with material compatibility. Material compatibility in terms of metal and rubber in contact with fuel is in most need to be evaluated all the way from the tank through the fuel lines and also in the engine. We need to be aware of all the materials where the methanol is in contact with. It's not worse than diesel, but other materials and other rubbers, other metals needs to be considered. So it needs to be evaluated all the way. So luckily, we have some experience from previous projects. We have a research institute of Sweden, RISE, who's been evaluating methanol fires and how to handle fire, how to handle leakages, and we also have an extensive, quite rigid experience from previous projects, both in my company, Scandinavians, but also in other companies and organizations for how to handle this type of challenges. This is the pilot boat before it was converted to methanol, and I will show you the next slide, which shows us the full conversion. You see? So I will go back again, and then we'll go forward again. So you can see that some components are added in the design, and I will go through them. There is a new methanol-powered engine installed. As I said before, we have the forepeak, and then after the forepeak, we have the machinery room. This engine is a methanol-powered engine based on a diesel engine. So I will go through it more in detail later, but the physical dimensions of the engine is like a normal diesel engine. The engine is connected to a gearbox, much or identical to any gearbox or reverse gear, identical to any reverse gear that is installed for a diesel engine. It has the same propeller shaft and the same propeller as they used to be with a previous diesel engine. So this means that the engine needs to have the same performance or the same drivability like a diesel, and it has, and that is what it's dimensioned for. We have double-walled fuel pipes and double-skin tank or double-walled tank. So if we take a look at the aft of the ship, we can see that there is a rudder room. So this is aft of the engine, and the gray unit you see there, that is the fuel tank. The fuel tank is designed from stainless steel, and it's designed as a tank inside a tank. So there is an inner tank and an outer tank with a small interbarrier space between the two tanks. The inner tank is filled with methanol, and the outer tank is then used as a second safety barrier, because we do not want to have a leakage in the ship. So if we have a leakage from the inner tank or from any component connected to the inner tank, we can simply detect and alarm for this, or send an alarm for this, but it's still kept in the outer tank, so it's still safe to operate the ship. The same goes for the fuel lines, which are gray in this illustration, from the fuel tanks up to the engine. those are double-walled. So if the inner pipe would have any leakage or if it would break, this would be collected and detected by in the inter-barrier space. So there's no risk for the people on board or for the safety of the ship. But I just want to emphasize here that it's a very simple construction. We replace the tank, but the tank has the same outer design as the previous tank. It's slightly larger to fit more fuel in, but we should remember that this is the conversion of an existing ship. We have leakage alarm for methanol leakage to detect this, and I give an alarm for it. There is one alarm placed inside the engine room. There is one alarm placed on top of the engine, and there is one alarm placed in the interbarrier space between the inner and outer tank. And we have for fire safety, as we said earlier, if we have a fire, the flame could be difficult to detect if it's bright daylight. And for this reason, the traditional smoke detectors are also complemented by heat detectors. So we have an extended fire detection system on board. So let's talk about the engine. The engine is based on a well-proven Scania V8 engine. It's a Scania diesel engine that is converted to operate on methanol. And this engine, which you see here in the photo, is the actual engine being installed inside the pilot boat. The engine is compression ignited, so it utilizes a few tricks to make this technology work. Traditionally, methanol is a fuel that is easier to ignite with a spark plug. You spray it, you mix it with the air, and then you ignite it with a spark plug. But this is not the technology we are using, and there are some reasons for this. And one of the most important reason is the engine performance. We want to have the diesel characteristics of the engine, the diesel performance. I will go more into that later. But to make this work, we need to replace a few components, critical components inside the engine. One is that the compression is increased to make the methanol burn easier, or auto-ignite easier. The second is that we are using a dedicated methanol fuel system for fuel injectors and the fuel lines on the engine. But then also the methanol is mixed with 3% of ignition improvers, which makes it behave more like a diesel fuel. I just want to highlight that this is not a dual fuel engine. This is a single fuel engine, which means that the fuel is a single fuel. It's a premix of methanol and the ignition improver, which is bunkered to the tank on board the ship. Then it's transported to the engine and ignited inside the engine as a single fuel. The engine it complies with IMO Tier 3, and IMO Tier 3, that is the strictest marine emission requirement for international ships. The one unique thing here is that it actually complies with IMO Tier 3 without utilizing any after-treatment systems. Normally, an engine that complies with this type of strict emission requirements need to use an after-treatment system like SCR, and then we also need to use the urea or the AdBlue. We are not using anything like this. What you see on the photo here is everything that is delivered to this ship in terms of the physical engine. And we can still comply with the IMO Tier 3. It's very efficient. For certain parts of the operation profile, we can have an efficiency up to 46%. On a cycle value, if you take into consideration of the whole propeller curve, low speed, medium speed, and high speed, we are well above 40% of cycle efficiency, which we are very proud of. The pilot boat and the engine is developed in cooperation with Lloyd's Register, so they have taken parts all the way through this development process in different types of risk assessments. And in a parallel project to the FASTWATER project, we have also been involved in a process for a DNV approval. And it's an identical design of the engine for the both for the Lloyds and the DNV here. These curves tells me as an engineer a lot of things. I don't know what it tells you, but I will quickly guide you through them. On the x-axis, we can see the same thing both for the torque and for the power curve. So we have all the way down from 600 RPMs up to 2100 RPMs, or 2000 as it's indicated here. And on the y-axis, we can see on the torque graph or torque curve that we have the actual torque in Newton meters. On the power curve, we can see that we have the power indicated. I will keep this short, but it's very important to show that this is the typical characteristics of a diesel engine. We are burning methanol inside a diesel engine and still being able to have the same characteristics of the engine. This means that the operator will not notice any difference if they drive a diesel engine or this one. That's important for many reasons, but for example, in an installation on board a pilot boat, this is actually a critical safety aspect. When you can imagine that you drive the boat in hard weather up to a larger ship, and then you have waves that takes you both back and forth. And you need to be able to have the immediate torque, the immediate response to get out of this situation. It could be reverse or going to sideways, but you always need this amount of low RPM torque from the engine. And also another detail here is that to be able to keep the same reverse gear and to be able to keep this size or this big fixed propeller, we need this type of torque to be able to install to propel the boat the way we like. Taking a look at the power curve, we can see that the power curve in the RPM between 2000 and up to 2100, it's quite flat, and this is also something we wanted to achieve. This means that the propeller matching is easier. We do not have to meet a specific point at the top maximum power. We have some margins to play with, and this is also something we wanted to achieve. So we're very proud of this. Scania has a broad engine program. We have developed this engine on board this ship, but we can also develop the engines for the smaller engines or for the larger engine, or the smaller engines, the 13 liter, and also the same 16 liter, utilizing the same technology. And we have examples from this, both from land side as mobile power, and also from the marine side as generator sets, and as in this case, a propulsion engine. And here are some examples of data sheets. Some conclusions: the ship conversion and the engine. The ship conversion is very simple. It's based on standard components, and this is actually technology both when it comes to the ship and when it comes to the engine. This is technology that is available today. This is not rocket science. This is not future technology. We have shown in this project that we have the technology available today. The engine has diesel-like drivability, and it's super clean. We have no particulate matters. We have no SOx. NOx is reduced by 75%, and it's now CO2 neutral using renewable methanol, in this case from Södra. Scandinavians and MR engines are ready to take on new challenges. So thanks from the Scandinavians team. I hand over to you, Fredrik, for some closing words.
Thank you very much. Yes, thank you, everybody. I hope you had as interesting day today as I have. For the audience here in the room, you are now welcome out to the jetty and look at the pilot boat. And I want to thank all the audience that we had online today. It's been a great pleasure. And I also want to take the opportunity from the Swedish Maritime Administration to thank today's speakers. And all the people, the organizations, and all the companies that made this project possible. Thank you very much.